Hello everyone, welcome to another episode of your weekly dose of Terraform. My name is the same, Anton Babenko, and this episode is going to be a little bit unusual than the rest of episodes because it's going to be a little bit less, how to speak, less hardcore or less even technical maybe at some places, because I'd like to show and to discuss one of the products which I'm partially affiliated with, and they are supporting me for quite a long time. Hello, Lucas from New Zealand. Oh my God, it's so far away. And so yeah, good evening. This episode is going to be me talking about Cloudcraft. I will explain what is this in detail, maybe from really user perspective, and I will also, of course, show some things related to Terraform. Otherwise, there is no need to have this stream in first place, because Terraform is awesome, and there are a lot of things which I want to share with you guys. And I will actually explain how to get infrastructure created in Cloudcraft, in Visual UI, in browser, and how you can get started with Terraform from that diagram. So I will show different ways, and I will actually try to make it end to end. The time frame for this session is 1 hour, so I will try to make sure that I put time frames or time codes into the description of the video once it's done, so you can check it later. So without further ado, let's get started. Well, there should be some words said about different things. So first of all, weekly.tf is a newsletter which I publish every Wednesday now, because it seems to be the best time. So weekly TF is pretty much covering everything what is related to news. So if you are interested in receiving weekly emails, and where I find different things which may be helpful for you, like this series of Terraform automation and collaboration things, different articles, different products, different solutions which I put into this newsletter. So check it out and subscribe to this one. And what else? N0 is again supporting me, and they supporting this live stream. They have, when is it? Yesterday. Yeah, yesterday they made available free ebook which actually explains they explain different infrastructure as code frameworks, where they covered CloudFormation, IRM, Terraform, Pulumi, Crossplane. They also mentioned some things about Terragrunt, about serverless frameworks. So if you are interested, you can go to this blog post, n0.com, and then how much do you know about IAC tools. So you can download the ebook. All you need to do is just leave your email, of course. So I kind of agree with some things in the book, but not everything is 100% correct to my mind. So if you don't have enough understanding of what is actually all this field, I highly recommend to check this ebook, and actually you will have at least some opinion. Maybe it's not the best opinion, but at least some opinion. Some opinion is better than no opinion. Okay, let's move on. And 16th of June, exactly 1 month before my birthday, I will be having talk at AWS Open, or they call it Open at Amazon. It's going to be a conference on Twitch. This is going to be a lot of different talks. Well, talks are very short, like half hour. I think my talk is even less than that. My talk is, it's also half hour. Oh yeah, cool. So I'm going to talk about why and how use Terraform AWS modules. If you are new to Terraform, or if you have some difficulties, I will try to come up with some examples, literally why to use it and how to use Terraform AWS modules. I'm not going to explain how awesome Terraform is, because, I hope you can go to Terraform documentation and read about it, but I will really focus about Terraform AWS modules. So that's it. Well, yeah, I will definitely put this link into description to this video. And so let me put it here before I forget about it. And this one, yeah, I will put this in description. Okay, so let's get to the most exciting part. And yeah, Jack is here again. Hello, Jack is here again. Okay, so we have Jack with us, Lucas with us. Anyone else is watching? I see that there are more than 2 people watching, so hello everyone. Okay, let's continue. So Cloudcraft. Okay, what is Cloudcraft? And to do that, let me go to Cloudcraft website. Visualize your cloud architecture like a pro. Create smart AWS diagrams. If you literally go into large amount of blog posts, you will see this isometric projection and you will think like, oh, that's really awesome, I want to draw the same. Yeah, you can definitely draw the same. So you have to go to Cloudcraft CO, open free account, and then log in. Hello Berkshire in UK. And then when you open an account, you will have possibility to draw exactly these diagrams. Why I say exactly this is because free account does not have infinite grid. That's why it is limited on this like plate. There are a bunch of different customers using it, so not be very much surprised if you go to internal documentation of large amounts of these customers and you will see some diagrams which looks familiar. That's because they are using the same product. Hello UK. UK is really close to my heart because, as you know, I had background which showed English breakfast when I speak on Zoom, and people really understand that I like this one. So then if I scroll here, I will see serverless application architecture. And this is something what I will be focusing on today. As you can see here, the serverless application is pretty traditional and pretty simple, and that's exactly what we want to do today. So let me just go through this diagram and kind of explain what's going on here. So we have user, and then user vote using an application, and then his request reach API gateway. Then this API gateway calls AWS Lambda function, which then talks to DynamoDB table, which then triggers another Lambda function, which tallies vote and generates static HTML. So then second time when user goes to this page, his request is going to be, let's say, he wants to visit a result page, then DNS servers called Route53. I don't know why it's invoked here, not here, but anyway. Then his request is somehow going to static content, which is stored on S3. So as you can see, there are really few components listed here, and I will illustrate this and draw this exact thing from the user perspective. Okay, we're not talking about Terraform just yet, but I will definitely focus on Terraform as well. So I just want to make it really as simple for people to understand as possible. Hello, Armenia. Oh my God, that's not really big time difference. It's like 2-3 hours from where I am, but still great to see you guys. Okay, other features which Cloudcraft has is, it is actually AWS optimized. There is stable amount of requests coming from different other cloud providers who wants to have the same, like Azure, Google, of course, everybody wants to have the same. You also have access to some information which is extracted live. For example, you can see, you can create some infrastructure and then you can see how it performs. Right. Hello, Giri from USA. And one of the requests which I have heard many times from people is that, well, everything looks fine, but I hate this isometric projection. I was even asked a couple times during conferences, like after I gave my talk, then people grabbed microphone and said literally, "Oh, I like this one, but I hate isometric projection, so your product sucks." And then I showed them that, hey guys, there is an option to make the same diagram in your flat projection, not necessarily isometric. And then this guy was like, "Oh my God, where have you been earlier? Because I was struggling with it for quite some time." Okay, and a bunch of other things. So let's log into this one. Well, that's a little bit complicated. So I will make a new one, create new blueprint here. As you can see, it asked me for blueprint name. Well, it's going to be your weekly dose of Terraform. Oh my God, no, it's impossible to pronounce. Let's just call it Terraform. Okay, so Terraform is going to be where I'm going to draw, and I want to make it infinite. So this option is not available for free accounts, but believe me, a lot of things you can put into one. I saw, I think, about 60 different resources placed into this one. It was pretty hard to navigate, but it was fun. Okay, so infinite grid is what I like. So then what I want to do, as I pointed earlier, I want to focus on serverless infrastructure. So I will pretend that I'm developing architecture for similar type of product where we have, let me move some of my streaming things somewhere here because it's just in the way of my flow. Okay, so here is it. So we have user. I guess everything starts with a user. It's not required, but it's just cool to have user. We can have many users if we want. We can have family of users. So let's have these two guys here. And yeah, we can make even different colors. Isn't it cool? I think it's cool. Okay, let's do something else. So what do we have? We have to do the following. So from here, we are gonna to reach an API gateway. So these guys want to send some request, and we need to. So what do we need? We need to have an API gateway. Where is it? Here is it. So it's under app services, which is okay. So it doesn't really match the convention which we have inside of AWS Console, but even AWS guys have a lot of issues with that. So it's okay to have it under app services. So inside of API gateway, we have, so once we put it here, then we can specify what type of API gateway we want to have. I'm big fan of HTTP because it just makes sense and it's cheaper and it really works in all of cases where I use serverless. I don't think I ever used REST since HTTP was released because it's just unnecessary. So I will pick this HTTP here. Here we can also specify number of requests. So here we specify 5 million requests per month. If we change it, then we can see that price is also changing. Cost estimate for 1 month of use. Okay, I have no clue how many requests we will have, so it's okay to leave it like this. Seems like a cool tool. No support for GCP as far as I see. Oh yeah, so that guy is really right. So there is no support for GCP, and I can tell you that this is partially intentionally because complexity between different providers is rather different. And it's just, if you really want to have tool where you can drop everything, like literally all kind of components and everything like a big ball of mass, there are a bunch of different products like Draw.io, for example, is pretty big. Well, Draw.io, diagrams.net, they changed name. Where you can literally put everything in one place and you can somehow use it. But for AWS, Cloudcraft is actually taking into account properties of each resource. So as I said, one of example is that this API gateway has properties like what type, in which region it is located. So we can click here and we can select which region we want to have. I'm based in Norway, so I tend to pick up Ireland because it's my default region anyway. And well, that's it. So what else do we have? After API gateway is invoked, we will have some sort of Lambda function somewhere here. And what else do we have? Well, we have S3 bucket, right? Because we want to store some content there. We will just put it somewhere here. And what else do we have? Well, we need to have CloudFront, right? I mean, CloudFront is definitely a helpful service here. Where exactly do we have CloudFront? Well, usually you put it somewhere here, right? You can put it into like in front of your API gateway, and well, I can make it a little bit bigger. Since I have infinite scale, I can do this quite easily. So we have human who is gonna to talk to CloudFront, and then CloudFront is gonna to invoke an API gateway. One of the reasons why you can do this, or why you should be doing this, is that you will probably want to do some other logic inside of your CloudFront. While you can also use custom domains inside of your API gateway, it's sometimes more powerful to do on CloudFront because you can add extra functionality on CloudFront. One of which I've been using quite recently is Lambda at Edge, as well as CloudFront functions, which were released literally months ago. So it's really a powerful service. And in many cases, it also improve performance a lot, even if you have dynamic content here. So then we have another request. We can also say that from CloudFront, there will be request to this S3 bucket, which will contain some static things. Let's give some names. So maybe it's S3, well, we call it static bucket. Just for fun, it's easy to call things here, and we can put it like this. So now, when you have few objects, you may already you may have your head already turned on one side just to read this, like I sometimes do. So I click here 2D, and then it's much easier to understand what's going on. So we have this pink human talking to this service, which is, if you're not familiar with icons, believe me, you're not alone. Even AWS employees doesn't know icons and services, especially whether this service belongs to Amazon or to AWS. That's a lot of fun to chat to them, and then they say, oh no, it's not Amazon, it's AWS service. Okay, so we call it CloudFront, but we can, let's call it CloudFront. Okay, so human talk to CloudFront. CloudFront made reach to S3 bucket, which is called static bucket. Or if it is dynamic content, then we hit this API gateway, which we can also give name. Well, we can call it API gateway. What a unique name. Let's show this one. I think it's not worst still. Okay, then API gateway will talk to Lambda function. As you can see, when I click on, when I select this service, there are three options: error connection, line connection, and text label. I like to pick error connection for a few reasons. One of the reasons is that it just indicates the flow of request, where from some point it goes to this one, to this one, to this one. But you can also do this in another way. You can also draw it like this, if you want. everything is possible here. There are no restriction other than common sense. In many projects, you want to have some alignment, so you want to have, let's say, certain angles and some things arranged for you, so it's pretty handy to have it like this. Okay, so I will put it somewhere here just to have 45 degrees angle, which is of course not forbidden here. Let's give some name to this lambda function. How can we get it? We can tell this is lambda. Well, okay, let's give it lambda. As you can see, I'm not very creative today. But okay, lambda, API gateway, S3 bucket. What else do we need? Well, we can give a lot of other resources, but I think for this example, we'll just add DynamoDB table, because why not? This information will have to be persisted somewhere. And again, we will make arrow from this lambda function to this DynamoDB table, which we will call, how we call it, we can call it, I don't know, records or items. Items. That's maximum what I can create today. So lambda function gonna to reach to this DynamoDB table, which is called items, and that's it. As you can imagine, there are a bunch of other things which I can put here, like for example auto scaling group. Well, why on earth do you need an auto scaling group if you are talking about serverless? So not really a thing here. You can also put different blocks, just, I don't know, to illustrate. Sometimes people use it to illustrate like missing services. For example, there is no web application firewall. So let's pretend that there is a web application firewall somewhere here. We can call it WAF, web application firewall, and we can make it not so big. Well, it should be pretty big. Okay, not this one. Right, so something like this we can do. We don't need this human anymore. Sorry, human. So something like this you can put, right? If you are more creative than me, you can definitely put it from one. Yeah, you can build whatever you want, really. It's not the purpose of this stream, to be honest, to show my drawing skills. Okay, so this is just an example of how you can add different other information to this diagram just for visualization purpose. I hear a lot of requests from different communities and different people who say like, oh yeah, but I'm using service which is called, what was it, App Runner, which was released last week. I want to have support for these servers immediately inside of Cloudcraft. Well, the reality is that these services listed here are in use by 90% of all users. So there is not really enough reason to put all 217 services which AWS have into this list. If you really want to do this, you can put icon here. This icon is code deploy, because there is no service for code deploy. But let's say I want to show that, hey guys, in this thing I use code deploy. So then I can just put it here and say code deploy, which is AWS service. So AWS code deploy. And this is what I can do, right? So I put my little drawing here and I put different text around it, and that's pretty much all I can do. So icon is very powerful because you can go here and you can see a lot of icon set, as well as Azure, which is not a long time ago, I think, yeah, well, maybe a couple months or so. And here are a bunch of different services. We can put functions app, which is, as far as I understand, is similar to AWS Lambda. So let's say we put it somewhere here, and we call it Azure function. So again, the reason of this diagram is to show some sort of information. You decide what you want to describe. Cloudcraft has options to give you things like text label, which you can put something random goes here. So you put something here, or you can even put, where is it? Right, you can also put frames like this, which is helpful if you want to highlight some things like this. This guy, AWS code deploy, is important, and you want to just show it here, and you can change different colors. You can change, you can change a bunch of different graphical things. Again, this is not a competition of drawing, so that's why I'm not gonna to even have this one. But you get the point that you can put text, you can put images, you can put icons, you can put blocks into this diagram. Okay. And by the way, if you have any questions, don't hesitate to ask. I will try to show this as I go. Okay, so on this diagram, what else is missing? Well, I think nothing. It's perfect as is. So let's see what we can do with it. Well, bunch of different services here is not really is not really biggest problem. Okay, so well, let me show what else I can have inside of Cloudcraft. So this is an example of my diagram, and I can also click attach docs and write really plain text, some sort of explanation of what is it actually. So this is my diagram and the rest of text. I can also specify different headings, different piece of codes here. As you can see, this is pretty big text area which I can use. Well, if you are still here, and I'm sure that you are still here because I know that this is pretty interesting for many people, you would ask, okay, but this is all browser, this is modern. Now 2021, we need to have an API, we need to have a way to control this stuff as at least as API requests. And I have good news for you. So if you click somewhere here, and then if you click API keys, I guess, yeah, and then refer to API reference on this website, you will see, I mean, this is my key, which I created. And here you will see information about all API. So yes, there are quite a lot of different endpoints. So there are ways to interact with large amount of your diagram. So for example, you can list and you can do everything with your blueprints, so that you can update blueprints, for example, or you can see what kind of accounts are connected to your Cloudcraft account, which AWS accounts are connected to Cloudcraft accounts, as well as you can also see the budget for this diagram. So budget is quite interesting thing, which I'm going to show here. So right now I put some components, I connected them the way I wanted. If I click on budget tab now here on the left side, then I can see that this is going to be my cost. And the cost is already break down into different services which I have. So Lambda, S3, DynamoDB, and API Gateway. As you can see, there are properties which I can specify in each of these services. For example, number of requests, or memory allocated for Lambda functions, or duration of Lambda function. And this is pretty much what I wanted to have, at least as a like high-level view, because at this phase, I'm not gonna to execute anything yet. I'm just seeing like, oh yeah, that's a lot, but what if we just put, I don't know, 3 gigabytes of memory, oh my god, it's actually gonna to be even more expensive. And then we suddenly got what is this name, slash dot, no, slash dot, well, anyway, if you get on the homepage of Reddit, you get more, oh my god, you have thousands of, no, 100 millions of requests. It's gonna to be a lot, right? And then if you suddenly decided to run it for 2 seconds, oh my god, what about 20 seconds, oh my god, and then this one, oh my god, then I went bankrupt completely. So you can get at least an understanding of how, like what kind of price estimate you have. In many cases, you have no clue how many requests you will get, but at least you have some rough understanding of what's going to be. And let's see, well, it doesn't really matter here. So this is just pricing, and you can see you can specify different currencies. You can predict by customizing, like on demand is usually twice as more expensive than provisioned, but with provisioned you need to remember yourself. Strong consistency, eventual consistency also has some cost implication, as well as a bunch of other things. So you can also filter this by different regions, because maybe Lambda in one region is not the same as Lambda in another region. So here is good playground for you, and I think this playground is actually even better than AWS calculator. Oh, calculator.aws, of course. Well, they have changed it quite recently, but in general, it is similar point, is that you create an estimate and then you drop a bunch of different services somewhere here. I don't even know where to start, but yeah. So here is similar type of information which you can get. Anyway, this is calculator.aws, but we are talking about Cloudcraft. So what else you can do here? Well, I'm not really sure what else are you looking for, but in most cases it's helpful to know that it's going to cost you this amount of money, and if I use 3 gigabytes. Okay, so what else I can do here? Of course, it's half hour past, and it's time to talk about Terraform, right? So Terraform and how it is actually related here. Well, you already, as a cloud architect, visualize what you want to have. You want to have these services somehow connected. What if you click on export and then Terraform code export here? And then it asks you, like, are you sure that you want to share this diagram with a third-party service called modules.tf? And you think like, yeah, why not? What is this? You go on this GitHub project, you go on this page, you click star here, that's really important. You click star like this, okay? And then you see, oh, that's actually diagrams to code, D2C, infrastructures code, and then you see all of this. And yeah, that's it. So I think it's quite obvious, right? Okay, so then you decide to export code. So what's gonna to happen right now is that you will get a zip archive created for you. It's called Terraform zip, because the name of the blueprint was Terraform. So now I'm gonna to switch gears, and I'm gonna to show this code inside of my IntelliJ, which is gonna to be, well, where is it gonna to be? Right, okay, so here is it. I just copied this, unzipped this archive and moved it to tf-dos Terraform. So here is the content of this zip archive, which I just got from Cloudcraft and from modules.tf. Let's look into inside of it. So the first thing which you can identify is that there is file readme md, which actually explains in details what is it and how to use it. I will not follow this myself now, but I hope that you can read this, and if there is any uncertainty, you can open an issue or reach out to me and I can help you with it. In essence, it means that you need to have Terraform and Terragrunt installed, and then you need to provide some access to your AWS account. And here is an explanation how to actually create the infrastructure which you just visualize. It's quite straightforward, but still it's important to explain the way how Terragrunt works. And actually, what is Terragrunt? So the first thing which you need to understand is that Terragrunt is a tool which is used to orchestrate pieces of Terraform configuration, okay, which is called Terraform modules. And the code which is generated by modules TF is actually Terragrunt project, which is inside of folder called Terraform. So if we go inside of Terraform folder, we will see few folders here. Each of these folder is called as we wanted to call it while we were drawing diagrams, right? So we created an API gateway, CloudFront, items is our DynamoDB table, Lambda, and static bucket. Now, if we look into each of these folder, like for example, static bucket, what we will see is a piece of code which does the following. So it tells to get source of the Terraform module from this location of this specific version, and it will pass this input, which is bucket equal static bucket, because that's what we wanted to do. That's how we call our bucket in the diagram. And it's going to pass this variable into the module. And if we execute Terragrunt, then we will have this bucket created. That's it. There is no magic involved into this one. On the other side, if we look into other folders, we will have another configuration properties for other things. Like if I look into Lambda, for example, here you can see similar piece of code where it says call this module, which is Terraform AWS modules, Terraform AWS Lambda of this version, and function name is going to be the one which I specified on the diagram, because that's what I wanted, as well as handler and memory. Memory is actually taken from the diagram as well. And the source path is going to be this handler pi, which is inside of this folder. This is just hello from Lambda, but of course you will have to put real code here as you move along. If you, like, one of thing which I hear from people, and I completely understand their frustration, is that what else can you put here? Like, can I put, I don't know, tags equal some map name, or name, no, well, name is not my, I don't know, code, for example. Can I put something like this? In most cases, you don't know exactly what to put here. So that's why there is a note which says view all available inputs for this module on this link. So if you go to this page, I will open it right now here, you will see that there are 90 different inputs and 24 different outputs which you can customize and which you can put in different combinations. So, okay, now you're like one step further. You can definitely read through all of this 90, and then you'll think, like, oh my God, what I can put in this, like how to combine even this. And that's exactly where the point of Terraform modules is coming into action. You click on examples, and these examples are going to show you exactly what you can do. For example, just by reading this, you can understand that if you want to build package, you probably have to click on this example and see how exactly Lambda package can be built. If you want to see complete, like really a lot of different options in one piece, which is very seldom going to be used all at once, but you can at least see how they're interacting and what kind of options are there. Or container image, or some other things, how to do deployments and a bunch of other things. So if I just go to, let's say, well, which one I like. I like complete. If I click complete, then I can read again what's going to happen. That this directory is going to create lambda functions, layers, aliases, and a bunch of other things. And then I can see again what kind of outputs are going to be exposed. But in most cases, you already want to go to the source code and see exactly what is this even mean. Like, okay, so when I call this module, then I can customize these things. So source path here is the same as source path inside of Terragrunt HCL file. And a bunch of other properties which you can read here. Okay, let's go back to the code and let's actually let's do the rest of magic. Okay, so tags was also supported, or is also supported by this Lambda module, but I'm not going to put it here because, well, I just don't need it here. But I can put it because it's supported. Hello from Yerevan. That's well, Yerevan is pretty far as well. It's like 3-4 hours, I guess, from Oslo. I mean, time zone wise. Okay, let's see what else is here. If I look into other properties like API gateway, for example, I will see that the properties which I specified there, like name of resource or protocol type, were actually taken into account from the diagram. So what it means is that information which was already planned and which is already available inside of your diagram is going to be taken into account. But this is not all. I will show a little bit more in a second. Okay. Now let's finish with this example. So what I want to do, well, at the end of the day, I want to get started with it, right? So I'm gonna to switch somewhere here, I guess, and I'm gonna to go to this Terraform folder. That's where I have, let me show 3. So the structure of the archive which I just showed is the following. Inside of a root folder we have a folder with Terragrunt configuration. Oh my god, even Australia is there. Well, I'm not surprised. If New Zealand is there, then Australia is also here. Great to see you guys. So we have Terragrunt configuration files created inside of region which I wanted to have. So all of these services are there, as well as placeholder for your infrastructure specific modules. Like in my case, it's AWS data, which is just reading information about existing availability zones, and then this information can be referenced inside of other places. So what I can do right now is that if I go to Terraform, and if I go to, let's say, static S3 bucket inside of EU West, if I go to static S3 bucket, so this configuration file is here. What I can do, I can run Terragrunt init, it will download this module. It should be fast, so that should be no problem. Yeah, so inside of static bucket, we can see that there is folder created which is called Terragrunt cache. So the content of the module is actually placed inside of this internal folder, which is this one. So this is the content of the module. So now when I initialize this one, I can run Terragrunt apply. And if I run Terragrunt apply, it will do pass the arguments into Terraform. So Terragrunt is just telling how to handle initialization of this module and how to pass values into that. So here, that's what I did. I run Terragrunt apply, which is similar if I would go into this Terragrunt cache folder and if I run Terraform apply inside of that folder. Terragrunt does a little bit more, but in general, it's rather similar. So when I run Terragrunt apply, I can see similar output as I get used to see when I run Terraform apply, and I can type yes, and then it would create this bucket. So that's the plan, right? Bucket already exists. Well, that's not not unique. So of course, static bucket is already created. But I was really surprised that in one of project which I have, we managed to grab a bucket which is called fixtures. So fixtures is actually our bucket, which we use to keep fixtures now. But as you can see, static bucket was already in use, so I have to use static bucket and then some random number, which is pretty expectedly, I would say. So now if I run Terragrunt apply and I confirm it, then I will get this bucket created, and that's pretty much it. Right, so what I have just done, I got the whole configuration, and then I created just one piece of it, right? I just created a static bucket. Now what I want to do, I want to go to Lambda folder and do the same. Terragrunt init, Terragrunt apply, and you already see that it's starting to get boring. So it's time to do something else, right? And this is how you can do this. So once you went through the configuration of these files and you made sure that this is property which you wanted to use, you can try your luck by going to the parent folder, which is either EUWest1 or even the whole Terraform folder inside of your project, and run the following command, which is terragrunt run all and apply. So what this will do, first of all, it tell you like, are you sure that you want to run Terragrunt apply in all of the folders? And as you can see, I'm located inside of EUWest1. So it will actually go through all of this and execute everything what I wanted. There is also no need to run Terragrunt init at the beginning to download the module, because apply will automatically look if this module was already initialized, then it will not do anything. If it was not, then it will initialize and then apply it. So here I say yes, because I really want to do execute in all of these folders, and I want to have a bunch of things created for me. So I just click yes. And what I'm expecting right now is a lot of output. This output is pretty much impossible to understand or to track or to even understand which place it fails. This is a problem of Terragrunt output to my mind. But what is happening already right now, you can see is that I will just scroll a little bit up to explain. So once I confirm that I want to do this, Terragrunt start to initialize backend, downloading all required providers for each of this module, and then it starts to execute the code. So it executes Terragrunt apply inside of S3 bucket. As you can see, it was already created, so that's why there is just output for it. Then it tries to execute code inside of API gateway, and then it created an API gateway for that one. And then it tries to build Lambda function and put it. So this code is for Lambda function. But also you can see that there is another line for CloudFront somewhere in between. So this output is very unreliable in terms of making a decision, because the Terragrunt understands that this code can be executed in parallel flow, so it will do as parallel as possible with certain limitations. But anyway, CloudFront is being created at the same time as Lambda function, which is okay, but you may have a little bit surprise when you see output, or especially if you see an error, it will be hard for you to understand which part exactly made this error. But here you can see that resource was created, and then CloudFront function, and then DynamoDB table was created, and then 7 resources were added, probably related to Lambda function, and that's it. So a bunch of different outputs which was semi-useful in many cases, at least to make a decision. But as soon as there is no error at the end, and there is no error at the end, which is pretty good, that's pretty much it. So we got our infrastructure created. Instead of us going into each of this folder and make Terragrunt apply in each, we just went to the parent folder and run command Terragrunt run all apply. So how I can prove that this was actually created? I guess you guys want to know that it was really created. So, well, there are two ways how I can prove that it was created. First, if I go to my account and if I select, I have a bunch of things here, and then this static bucket was created here. As you can see, it was pretty much 3 minutes ago. So the same I can go for other resources and they will be there. That's not the problem. So, okay, you had this guy created here. You have your Terragrunt configuration. You have created an infrastructure, and well, that's pretty much it, right? Pretty much. Now what I want to do is the following. If I click on Live tab inside of Cloudcraft and then I select that I want to go, well, it's all in one region anyway. So if I click Scan Now, I will see a lot of resources here, including those which I really wanted to see. For example, my S3 bucket here. So Cloudcraft was able to read my AWS account and present information which it knows about. So here is Lambda function, which is called Lambda, and there is static bucket, which I just created, CloudFront distribution, and so on. So that's pretty much what I wanted to see. Let me do the following. If I click on this static bucket now, and you can see that this static bucket is looking similar to this one, but it has a little bit more option, right? It has option, not option, it has this orange circle, like refresh thing somewhere at the top. And it has also another title, not title, another text label style written above or below. So why I'm saying this is that now I can do the following. So this was my original bucket which was created, and this is the bucket which I have just created. Okay, so let's see what I can do. How can I make this diagram more actual? Because in fact, I don't have bucket which is called static bucket. I have this bucket which was called static bucket 3 something. So one way to do this is that I can just use this thing here. So if I put this arrow there, then I don't need this guy anymore, right? I can simply remove this one. So the same I can do for many other services. As you can see, like, what is the main purpose of such replacement is that now when I have this orange thing at the top, I can actually see the changes inside of my diagram. So of course I cannot rename bucket without recreation, but I should be able to change, for example, volume type. Is it such property of bucket? Well, or is it property of object? I guess it is property of object, right? Well, anyway, what else I can change? Server-side encryption disabled, right? This one I can change. Let's see how I can change it. So again, what I want to do is that I want to change property of this bucket and see my updates in my diagram. So let's see how I can do this. If I go to configuration for my bucket, okay, so this is my Terragrunt HCL file inside of static bucket. So somewhere here I need to write block which enables encryption. Again, I don't know what, like how to do this, so I have to go to the source code of the module, or I have to click on this link, and go to the registry and see it there. So I prefer to go to the source code because I know that there is the same code in examples inside of maybe complete main. So here is a bunch of different code, but I'm specifically interested in some server-side encryption enabled. I think this is it. Right. There is no other type, right? No, there is no way to specify type of object inside of bucket. It's per object itself. Okay, so here is server-side encryption configuration, which I take from example and I put it somewhere here. There is, let me see it here. Just 1 second, I want to find. Tick, 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 tick. Okay, yeah, it's a little bit wrong code which I copied. Where is it? This one, right? So I used to say server-side encryption algorithm is not KMS because then I need to create KMS key, but I don't want to do this. So I specify that I want to use advanced encryption standard. I think this is AES inside of this bucket. So what I can do right now is, again, inside of my parent folder, I can go and run Terragrunt, run all, apply, and it will apply changes, apply all pending changes if I made them, let's say, in CloudFront or in Lambda. But in fact, I already know that I changed just static bucket, so I will simply go there and I will just run Terragrunt apply just in one folder because that's what I want to apply. So if I run apply now, and it should tell me that it's willing to change this server-side encryption configuration. That's cool. So I click apply, and it was successful after 4 seconds. And now if I go to, as you can see here, it says server-side encryption disabled, right? So what I need to click somewhere here, well, somewhere here is, I guess, this one, scan now. And now you can see that server-side encryption enabled and using Amazon managed S3 key. So this kind of integration is very helpful for me to really know, like once I draw this one, then I created code for it, and then I start tracking some changes. Of course, I can use different tools which are much more complicated and much more powerful in terms of information available in them. One of such tool is, of course, you guys know, which is called driftctl, right? Where you actually want to compare how your code is different from the one which you like. It can compare pieces of code and pieces of configuration, but here we do different things. Here we are just visualizing parts of our AWS console here, which is somewhere here, static bucket. I guess management. Well, I don't know where I'm clicking really, but somewhere here it should say that this bucket is encrypted. Probably it's properties. Yes, so here is it. But as you can see, it's not very convenient to go through this UI, at least for some people. So you just want to see whether this was encrypted, yes or no. So all you have to do is just click scan now periodically and see some changes. Well, you can do the same thing for many other resources like CloudFront, for example. In CloudFront, you can also specify whether this was enabled or disabled. or what kind of origin supposed to be used here as well. So I'm not gonna to replace this box, but I'm just curious to see what kind of information is available for Lambda, for example. So for Lambda, it also knows runtime, name, timeout, and the size of the object. So some of these things you can definitely change in the code, and then they will be visible inside of this UI, like memory usage and timeout. You can change in the code, and then they will be reflected here. Okay, so this was pretty much the last point which I wanted to show here. And as you can see, starting from the diagram here is usually a very good idea for many reasons. Like one of the most common reason is that it's much easier to show a picture instead of explain on fingers and say like, oh yeah, it's gonna be there, and then hit this one and that one. Now you can actually take this one and export this as an image, and of course you need to embed it into some Confluence if you want, but I can simply download PNG or any other format, or I can also somewhere here I can embed this into Confluence, and if I embed this link into, let's say, Confluence or any wiki, people will be able to interact with it as well. They can zoom, they can see different properties and so on. So that's pretty much it. Does anyone have any questions about what I just did, or Cloudcraft in general? Please reach out to me. While you guys are thinking if you have questions or not, I can tell you how to delete this, right? You may use some of the code for proof of concept and then do something else. So here, as you can see, let me just collapse some of these folders. Here, all of this code is in configurations. Why would you even take this approach seriously, or why do I want you to take this approach seriously? It's a pretty important question, which I've been asked many times by people who say like, oh yeah, but it's too complicated. Well, it's maybe too complicated if you don't understand the main like principles on top of which this solution is built. And once more, let me just reiterate. The solution is built on the understanding of that your AWS provider infrastructure is regional. So that's why there are folders like EU West or some other region. And then there are a bunch of services inside of that folder which you can customize. So some for API gateway, CloudFront, and so on. All parameters are readable inside of just HCL file inside of input. So this is feature of Terragrunt, which is very well documented, and there are zero problem with that one. What you can do additionally here is that you can run commands on just some of these folders. And Terragrunt itself is pretty big. I talked about it at least 2 times during these streams before. So if you're interested, just search on YouTube previous episodes, and well, they were pretty deep in understanding of what is Terragrunt. So once you have this code created, what else you may want to have is yeah, you're welcome, and it's my pleasure to make sure that people are aware about these tools. So what I just want to show you, we have a little bit time left, so I will just show briefly. So now when I showed that in this high level or high root folder or original folder EU West 1, I can run command for Terraform, which is plan, apply, or destroy. So if I now run destroy, it will tell like, are you sure that you want to delete? There is no undo. Well, what can possibly go wrong? And yes, I want to delete all of things which I just created here. So I said yes, and it's gonna to delete them pretty much simultaneously. So here is the tricky part. As you can see, it's been deleted. I will finish this one, and then I will show you like extra feature of modules TF as well as Terragrunt, and the feature itself is in relations. So here we have pretty few relations, right? There are no relations actually. All of these resources are being managed in isolation. So for example, if you change something in Lambda code, there is no chance that you will break CloudFront, or there are no relation between API gateway and Lambda functions defined inside of the code. So for more traditional workload, like let me show you. So it will just delete and then it will succeed. There is really not much to talk about it. Let me show you one project here. So here we have a more traditional application, right? It's 3-tier application where we have load balancer in front. Then we have, well, I can probably show you even this one here. Yeah, it's the same diagram, but just easier to navigate. So on this diagram, we have much more resources. Like overall, we have VPC. Inside of the VPC, we have a bunch of different security groups, like one security group for load balancer, one security group for this auto scaling group. Then we have another internal load balancer, and so on. So we have a lot of different resources connected. Where exactly the challenge with Terraform and Terragrunt is, and like why Terragrunt is so efficient way of solving some of this problem, is think about the order of how this resource will have to be created, right? So first of all, as you understand, you need to create VPC, right? You need to create VPC before you can create this security group. Once you create this security group, then you can create this load balancer. So in fact, if we just draw this, create new blueprint. So if I just drop, let's say, load balancer, and then I want to specify that it's going to be using new VPC, and this load balancer will have to have new SG. You can see that it's already expanding box, that one load balancer has security group and has VPC. So what if we click export now and get Terraform code for this one? I didn't do this myself, so it may be producing strange result, but anyway, this is live demo, so it should be strange anyway. Right, so I didn't give name to this blueprint, so that's why the folder is undefined. Pretty cool name. So here is this folder undefined, and as you can see, there are a little bit more things than you expected, right? So first you have an ALB, that's what you just created. And then you have few things defined as a code as well for you, because, well, that's what you specified in the diagram. So that you specified that you want to have new, which is located inside of this folder new, which is actually VPC. And then ALB is also dependent on new SG, which is located in this folder, which is actually creating security group. So this is the relation how modules TF is converting from diagram into the code. So in order to create security group, we need to have VPC created, so that's why security group is dependent on VPC. And as you can see, the reference, like in which VPC to create, is using dependency dot name of this dependency dot outputs dot VPC ID. So it's going to be when this code is going to be executed, Terragrunt will look into creation of this new, and then it will get VPC ID and it will use it somewhere here. So it will be replaced with VPC dash and some number here. So this is literally what's going to happen by Terragrunt. So Terragrunt allows us to use these links inside of our configuration code. So here, as you can see, I have successfully deleted previous example. And as a very last thing, let me just try to run this code and see if it actually works, because I didn't think about this like in details before. So let me just see. So if I go to this undefined folder, and inside of undefined, all I want to do is just apply. Okay. Of course, I can do the heavy lifting myself by literally going to the folder which has no dependencies or has very few dependencies, like VPC, and then create this VPC myself, and then go to security group and do this myself. But that's not what I want. I really want to just go to this project and spin up everything what I just visualized, which will be VPC in a bunch of different subnets, as well as security group, as well as application load balancer with this random name which was assigned to it. Let's see. I'm not sure if it will work, because there may be some differences in, for example, in versions. I just bumped new version, but I didn't try this one before. Anyway, it's creating VPC quite successfully. As you can see, it creates a bunch of different resources, including all routes, subnets, and different other things, which may be unnecessary for this example. Well, they are unnecessary for this example, but you have pretty decent starting point. That's what I want to really emphasize. The starting point of such approach is very useful. So we created VPC, we create security group, and well, I don't see any reasons why application load balancer is gonna to fail right now. I mean, it should just succeed, and there is no reasons for it to fail. So as you can see, security group was created correctly, and at least 2 subnets. Oh my god, who knew that application load balancer requires to have 2 subnets in 2 different availability zones? Yeah, so it didn't work out. So somewhere here I need to specify subnets. Well, yeah, kind of quite obvious to my mind, but still. If I go to examples, and this example, if I scroll, oh yeah, sure, I need to specify VPC and subnets. Right. Okay. Yeah, it's a bug. It's a bug, and on this buggy note, I want to mention that the project which is actually generating this piece of code is completely open source. It is on modules.tf lambda. You can go there and you can see the logic which is used to generate this code. So I will just go somewhere here and fix this after the stream. It's quite easy for me to navigate, but I know that this code is far from ideal. Anyway, on this note, I want to wrap up, and I want to say thanks to everyone who attended it. Let me show my big face visible. So thanks a lot for people from all around the world, and I wish you all have a great night, day, or morning. It depends where you are. Thanks a lot to you. Bye.